Hi there. My name's Aaron Lanterman. I'm a professor of electrical and computer engineering at Georgia Tech, and this is the Focusrite Red 3 compressor. Oh, and it looks like this one belonged to Blackbird Studio. That's interesting. I've always wondered what's inside this compressor. I've never been able to find any schematics. If anybody has one and feels like sending one to me, I would love to reverse engineer it. Anyway, I have heard a rumor that the discrete voltage-controlled amplifier in the compressor uses a MAT04 quad match transistor by Analog Devices. I have no idea if that's true or not, but let's roll with it. If you scroll down the datasheet for the MAT04, pretty much all the way towards the end here, we have to scroll a little more, you wind up with this schematic here. And this is for a voltage-controlled attenuator, which we'll generally just call a voltage-controlled amplifier, whatever. And of course, I have no idea if the Focusrite Red 3 uses anything like this particular topology or not, but this circuit is interesting in its own right, so I would like to try to understand it. Now, I'm not at all confident in the analysis I'm about to give you, so if you see me do something incorrect, or you have a better interpretation of the circuit, please let me know in the comments below. So I'm not going to try to understand all of the stuff up here today, and that is a bit of a cop-out because this, of course, really is the heart of the VCA. I'll think about that another time. What I want to do today is try to figure out the current generating circuitry that's down here. So you've probably seen stuff that looks like this in voltage-controlled amplifiers and synthesizers, where the signal comes into one of the bases, and then down here you have some sort of circuitry generating the tail current for this differential pair, and the control voltage comes in here. But here everything is flipped around. The control voltage is actually coming in here and being applied to the bases of these transistors. And this control voltage, I think it ranges from -3 volts to 0 volts, if I remember correctly from the datasheet. And the signal is coming in down here. So it's opposite of the way I'm usually used to seeing this in a synthesizer. So let me call the positive terminal voltage on the left here V star. Now, according to the rules of op-amps operating in a negative feedback configuration, assuming that's all working properly, of course that is an assumption, we have V star being cloned down here. And now take a look at this path through here. We have a path going down this direction, going this way, and then coming up through here, like so. And what I would like to do is I would like to start with a DC analysis. So what I'm going to do is I'm going to assume that this particular cap here is open, and then I'm also going to assume that this cap here is open. So we want to see what this looks like without any signal. So actually, I should probably make these capital V's, something like that. All right. Now, notice that if I have V star over here, that path I drew in gray going through here like this, notice that there's no current flowing through the positive terminal here. So basically, there can't be any current flowing through R10, and there can't be any current flowing through R1, since if there was current flowing through there, we would have a difference of the voltages going through that path, but we know they need to be the same. So V star here is determined by this voltage divider that's dividing our negative power supply over two 10K resistors. So I can think of V star, my steady state voltage, as being V minus divided by 2. Okay, now let me think about the currents here. Well, if this is V star and this is V star, of course, then if no current is dropping here, this needs to be V star and this is also V star. Let's assume that negligible current is flowing through the bases. So my bias currents here, I could say IA is equal to IB is equal to V star minus V minus all over 30K, these resistors here. So let's see, I would say V minus over 2, because that's our V star, minus V minus all over 30K. So let's see, that will equal to minus V minus over 2 divided by 30K. And let's see, if you assume something like a V minus of minus 15 volt, let's see, that would give us a current of 250 microamps. So there you go. Okay, so now let's do something like a small signal AC analysis. But I really shouldn't be using the term small signal analysis. It's not like we're creating a linear small signal model for these BJTs. The linearization of these BJTs is actually being handled by the op-amp. The op-amps are providing the brains of the operation, and the BJTs are just providing the muscle. So let's see, for an AC signal analysis, we'll imagine that the capacitors act as short circuits. So this bit over here is basically shorted to ground. So this is ground here, and then I'll have a virtual ground here. And let's see, if we assume that our signal is an ideal voltage source, then Vn is getting copied over here. Let me write that as a little Vn. So I'll have a little Vn down here. And again, assuming that there's no significant current flowing through the base, then the current IB, and I should say the signal current IB, so I'll write that with a little I, is going to be Vn divided by 30K. And then the actual current IB is going to be this plus whatever that bias current is. I think we figured out it was 250 microamps if you used plus minus 15 volt supplies. All right, and then over here, if we have Vn here and we have ground here, then there's a current flowing this direction. Oh, but notice something very interesting. In this kind of AC signal analysis, this is AC ground down here. We zero out that DC supply voltage, so I have ground here, so there's no current flowing through the resistor here. So that means that this current must be flowing up this direction opposite of that arrow. So IA is going to equal minus Vn over 30K. All right, so this is doing some sort of opposite kind of business. The last thing I'll mention here is that I have a lecture in my ECE 4450 Analog Circuits for Music Synthesis class where I look at a spiritual cousin to the circuit.